Welcome to the deep dive into Python data types. We're mastering the core architecture of Python programming by looking under the hood at how data is truly stored and managed. In Python, everything is an object. A data type is essentially the blueprint, the genetic code that tells the interpreter how to handle information. This blueprint dictates memory allocation, possible operations, and the object's unique identity in memory. Let's start with the atomic types. Integers offer arbitrary precision, handling huge numbers without overflow. Floats and complex numbers are for precision-heavy data science. Booleans, true or false, form the binary foundation for all program logic. Strings are not simple text, but immutable sequences of Unicode characters. Being immutable is critical. Modifying a string, like slicing here, forces Python to build a brand new object in memory. Repeated concatenation can be slow. This brings us to the mutability divide, the single most important architectural concept for writing bug-free Python code. Objects are split into those that can change, mutable, and those that are fixed, immutable. Lists are the dynamic arrays, the Swiss Army knife of Python. They are great for ordered collections that change over time. Be aware of performance. Appending is extremely fast, but inserting at the beginning is slow because all other items must shift in memory. Tuples are lists with data integrity. They are write-protected, meaning once created, they cannot be altered. This immutability allows Python to allocate exact memory blocks, making iteration faster than lists. As immutable objects, tuples are also hashable, allowing them to be used as keys in a dictionary. Sets are unique, unordered hash tables. They automatically destroy duplicates upon creation, cleaning up redundant data. They offer lightning lookups for membership testing, which is fast regardless of the set size. Sets also support native mathematical operations, like union and intersection. Dictionaries are the key value hash maps, the engine of Python. They store data you can retrieve using a unique label or key. Critically, these keys must be immutable, like strings, integers, or tuples, because mutable objects cannot be hashed reliably. Deep under the hood, variables are just pointers in a concept called pass-by assignment. They are labels pointing to an object's memory address, visible with the ID function. Changing a mutable object via one label changes it for all other labels pointing to the same address. Use .copy to safely duplicate data. For professional code, type hinting is essential. Explicit contracts tell developers and IDEs exactly what data types a function expects and returns. This enables static analysis tools like MyPy to catch errors early. It ensures professional scalability, making dynamic Python code more readable and easier to debug in large applications. To stay Pythonic, choose your data types wisely. Primitives, like strings and integers, are the immutable building blocks. The changeable types, lists and dictionaries, are your daily drivers for dynamic data. Finally, use the specialized types, tuples and sets, for locked data integrity or blazing fast unique math operations. Now, open your terminal and start practicing.